Hello. Hello. శ్రవణ్ నేను స్టార్ట్ బ్రాడ్కాస్ట్ ఇచ్చాను ఇంతవరకు ఎవరు జాయిన్ కాలేదు ఓకే 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 Hello.
Good morning, sir.
Good morning. Pranshul voice, Ahalya voice, who else? Ragini.
Good morning, sir.
Good morning, Amma. Why you are all late today?
Sir, we were not able to get the link on the website, sir.
I see. Okay, okay. The problem is with the transmission part then. Okay. Okay. All right. Let us switch over to our work yesterday that was pending. Some homework you were asking me, na? Doubts in homework. Come on. Come out with your queries, please. No, you tell me which date, assignment, and question number. You please tell me. What, my dears? No doubts? Hello. 87. 87 of which assignment, my dear? Number also, Ahalya. Assignment number, you please tell me. I will immediately open. 87. Oh, 87, I got it. 87, a battery of EMF E. Got it. Are you seeing my screen?
No, sir.
No?
No, sir.
Okay, okay, okay. I'll make you see 1 minute. 1 minute, you'll see.
I can't.
Are you seeing the screen now?
Yes, sir.
Right. I believe this is the question where you have some doubt. All right. A battery of EMF E. Are you seeing the screen now? Hello?
Yes, sir, we are able to see.
Okay, okay, fine. Then a battery of EMF E internal resistance R is connected to a load of resistance R. All right, let me draw the diagram first. It is a cell of EMF E and they are saying internal resistance is smaller. Oh, please. Okay. People are able to join now. Just now it's fine. Okay. Internal resistance is smaller and it is connected to an external resistance capital R. This is what? Express the following in terms of E, R and R. Let us look at the first one. Current in the circuit, number 1. What is current in the circuit? Total EMF by
Total
total
EMF by total resistance.
Yes, small r plus capital R over the PD across the load. Right. PD across load. Load means what, sir? The external resistance is known as load, I am writing. It is nothing but external resistance capital R. That external resistance capital R across that PD is nothing but terminal voltage only. What is the formula for terminal voltage? ER by R plus R. Yesterday also under potentiometer we used this link. Do you remember? ER by R plus R. That is PD across load. Okay. Then of course you can write it in the other way also, to be frank. You can happily write it is current into resistance. The current formula anyhow it is at the top. It is E by R plus R is there into R. So that way if you remember also you'll get the same answer. Let us look at the third one. That is potential drop. Potential drop across battery. What is potential drop across battery? If you remember in the introductory part I was telling you, that is also known as last volts. That last volts is nothing but current into small r. Current is nothing but E by R plus R. That into small r over. Then let us go for fourth one. Power delivered to the load. What formula you are going to write? Power delivered to the load. Power is equal to, you can use the formula V square by R. Then what is the voltage across the load we were saying? This is ER by R plus R whole square into 1 by R. So your answer is E square R by R plus R whole square. That is one more answer. The last one. The power dissipated inside the battery. Power inside. Of course, if you want, use the same formula V square by R. But what is V value lost inside? It is ER by the previous step, my dear. E r by r plus r whole square into 1 by r. That's all. Is it okay? Tell me, welcome, any more queries? My dear, power inside, I wrote V square by R, correct. That R is nothing but small r, na? So, your thing should be smaller. When it is smaller, it is this much here. It is this much here. So, if you slightly simplify, it is E square small r by r plus r whole square is coming out. Okay, that is about 88. Okay, question number 88, we'll look into that. My dear, shall I rub off this? Shall I rub off the present one? Okay. Then 88. Let us see that 88. I'll copy the question first. No, not this one. It may be this one. 88. Oh, the question appears to be definitely long. Okay. Then let us see what that is. $88. The source has an EMF A source has an EMF of E and internal resistance r. A load of variable resistance is connected to it. To receive maximum power, what should be the value of load resistance? I told you already. What is the difficulty? Then, all right, let us look at this 88. A source EMF E, as usual, EMF, internal resistance r. Some load is connected. That load outside resistance we call as capital R. Then what would be the value of load resistance if maximum power is being delivered to the load? Find the following. Maximum power transfer theorem, do you remember? What I was telling you, my dear, maximum power transfer theorem says that when internal resistance is equal to external resistance, you have written this, my dear, maximum power transfer theorem. Power transfer theorem. Okay, let us look at these things. A, what should be the value of R? That is, small r should be equal to capital R. If maximum power, the current in this, no, this is not A. Current in the circuit they are asking. Tell me, what is the formula for current in the circuit? Current
Total EMF by total resistance.
EMF by total resistance. Now total resistance is small r plus small r. Because capital R is also becoming equal to small r, na? That is the only given value in our data. So it is E by 2R, answer for A bit. Then B bit. What is that B? The power delivered. Okay. Power is equal to, you write this as I square into small r. That is nothing but E square by 4R square into R. The answer is equal to E square by 4 small r. Formula only, nothing else. Then let us come to the C bit. What is that C bit? The power dissipated in the source. Oh, this is power dissipated at load. Then power dissipated at source is equal to same formula I square R. So the answer is once again same E square by 4R, no doubt. And what about D? Total power delivered, power total. Obviously, it will be the sum of power delivered across the load plus power delivered across the internal resistance. So answer is how much, sir? E square by 2R. That is the power total. And what is the question? DE. What is E? The efficiency of the source. Right. Efficiency eta is equal to output by input. Do you remember efficiency formula from your 11th class? Anywhere power output by power input into 100, or it is not, I should say total. All right, what is the power output that is coming out? E square by 4R. What is the total input power given by the source? E square by 2R. It is into 100. If you want to express that as a percentage, it is coming to 2 by 4 of 100. The answer should be 50%, my dear. 50%. Then what else they are asking? E, F. The PD across the terminals. 1 minute. I want PD across the terminals. Tell me, what is the formula for PD across the terminals? It is ER by R plus R. Because small r and capital R both are equal, the answer should be E by 2. That is F. And G. PD across the terminals of the source. PD across the terminals of the load source, both are equal, then only maximum power transfer occurs, no? So ER by R plus R, then PD across, this is first one is what? Terminals, that is a TPD actually it is. TPD. And what is PD across? PD across load. PD across load also is E by 2. Am I right? PD across load is nothing but I by R. That is right. I will write I into R. That is nothing but E by 2R into R. The answer is E by 2 only. Then one more is there, H. Internal drop. What is the drop value? Internal drop. Drop is nothing but last volts. Last volts is nothing but I into small r. It is E by 2R. That is E by 2 only. Tell me, my dears, is it okay? Any more queries? Welcome. That is 88th problem. Is your noting over? 92, okay. 1 minute, my dear. Shall I rub off this previous one? All right. 92, okay. Let us see that 92 question. I'll copy it here and we'll discuss. 92. No, this is with the diagram, so I am copying as it is as a picture. 92. Right. Look at this. A charging source has a voltage 50 volt and negligible internal resistance. The accumulator being charged has an EMF of 36 volts, internal resistance of 1 ohm. My dear, that is not 1 watt, 1 ohm. That is ohm, of course. Here you have to think that this is ohm. 1 ohm. Oh. It is dominating the whole thing. It is 1 ohm. Okay. Find the resistance R in the circuit to give a charging current of 2 amperes. Okay. Also find the terminal PD across the load during the charging. Right. I don't know. Probably you might have solved this in the usual manner, but here you require little more extra knowledge, because when a cell is discharging, I will draw this diagram. When a cell which is connected to a resistor, capital R, and EMF is E, small r, is discharging. What do you mean by discharging? Sending current from positive to negative. What is going on? Charging. Under that case, current comes out. Then please remember, our formula is Vt is equal to E minus IR. Perfectly correct. But whenever you say that this is one accumulator, please see, my dear, accumulator is the other name for secondary cell. Secondary cell is one which can be charged. I told you, our mobile phone, inverter, battery, these are all known as secondary cells. In the beginning of the lesson, I told you. Now, whenever that becomes weak, we take the help of something and we will go for charging it. When that charger is here, please see in the diagram, charger whose value of EMF is greater than the cell EMF. EMF of the cell is hardly 36 volts. To charge it, they are using another 50 volt cell. Okay. Then they are asking you something. And remember, now this is the diagram where current goes into positive. This is positive. This is negative. From positive to positive, this positive should be higher. Then current is going into the positive of the cell. My dear, remember, that is known as charging. Previous diagram, when current is coming out of positive, it is discharging. Now this is charging. Whenever this is charging, terminal PD formula is not E minus IR, but E plus IR. Whenever charging case is there, that E is nothing but 36 volt. Then I, charging current, they gave already as 2 ampere. Internal resistance was given as 1 ohm. The answer should be 38 volt. That should be the terminal voltage. Something else also they ask. Find the resistance R value in the circuit to give the charging. Okay, but anyhow they are asking the value of R, which will produce 38. Okay, when you say terminal voltage is 38 volt, my dear, if you don't mind, I am putting here totally starting from here to here 38 volt. Then you have used 50 volt. This is 38 volt. When this is 38 volt, out of total 50, this remaining should be how much? 12 volt. Out of 50, 38 volt speed is appearing across that chargeable cell. The remaining, because they are in series, the remaining 12 volts should appear across this. And this is the value of R. You know it is supporting a current of 2 ampere. This is what was given. When it is supporting a current of 2 ampere, according to Ohm's law, V is equal to IR. The 12 volts should be 2 into R. It implies that the value of R should be what? 6 ohm. Oh, it is 94. 94. Let us see that 94. 94 is again a diagram Okay, equivalent resistance. Okay. I'll go for taking this. 1 minute. It is new 94 you want. That I am copying here. Okay. I'll put it here. Copy. Okay. This is our problem now. 1 minute. Small management. This is something to be rubbed off. Okay. A, B, B, C, C, D, D, E, E, F represents 5 conductors, each of resistance R. If BD and CE are joined by conductors, each of resistance R, find the change in the equivalent resistance between A and F. Wonderful. You know, let us say that first they are not joined. When they are not joined, what is the value of R total, sir? R between A and F. They are saying that totally there are 5 resistors. It should be series, no? R plus R plus R plus R plus R, because totally 5 resistors are there. We know the answer is 5R. Now when they are connected like this, with resistance R, if you don't mind, I will draw the same picture. No, this is what slowly you have to understand, my dear. It's not difficult. See, I am saying this is B. This is C. Okay. This is E. From E there is one more connection. If I call this as 1 minute. This is E. From this there is F. They are saying that this is R. CE is also given as R. BC is R. BD is R. DE is R. From A there is one more link, A, like this. Now between C and D also there is something, R. But now as you are seeing here clearly, shall I say that this is something like a balanced Wheatstone's bridge. So between C and D you have to think that there is no resistance. Once if you say this resistance is not there, your picture appears in this fashion. This picture is appearing in this style. Now can't you not tell me, sir? R, 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 R. So obviously the answer is, for this entire thing, what is the resultant? 2R, 2R in parallel. So it is R only. This is A terminal. This is F. This implies that the resistance between A and F is equal to 3R. They are asking, therefore change. The change value should be equal to 5R minus 3R. It should be 2R. Over. No, understood, my dear? Vamsi Krishna, understood? Okay. Now you please tell me if you have any more. It is only just seeing the diagram in the given style. Tell me, my dears. Oh, 100. Okay. It is 100. Maybe from assignment, same number, 100. Okay. New 100. Okay. Let us go for looking at this 100. A potentiometer wire 4 meters length has a resistance of 10 ohm. My dear, this is nothing but ohm. It is ohm, no doubt, it is ohm. OHM. It is 10 ohm. Okay. 10 ohm. It is connected in series to a resistance of 20 ohm, and the combination connected to a secondary cell of 6 volts and negligible internal resistance. Find the potential gradient across the length of potentiometer secondary cell. Okay. Why can't you draw the diagram where you are facing difficulty? It is a wire. It is a wire of length 4 meters, and moreover it is saying there are 10 ohm resistance it has. It is connected to some 20 ohm in series, and it is connected to a cell. The EMF of the cell is 6 volts. Small r is negligible, 0. Then, my dear, why can't you find, my dear? This A to B is potentiometer wire. What is the formula used to calculate current? Our stock formula only. Total EMF divided by total resistance. Total resistance is 20 plus 10. It is coming to 6 by 30. It is as good as 1 by 5 ampere current is flowing. Now, they are asking, what is the PD? What is PD across AB? PD is equal to I into R. It should be 1 by 5 into 10. It should be 2 volt. When you know PD across that as 2 volt, they are asking potential gradient. Potential gradient is potential calculated per unit length. So total potential is 2 volt and total length is 4 meter. It should be 0.5 volt per meter. That's all. Tell me please, what more? That's all? No more queries? $105 for Ragini. Okay. My dear, I'll go for rubbing the screen. 105, let us see. That is, must be in the next one, no? Oh, it is not here. It is in some other 106. 105. Let us see that one. 105. I'll copy this. Snipping tool. One not six. Okay. 106. An ammeter and voltmeter are non-ideal. If an ammeter reads 1.5 amperes, voltmeter reads 4.8 volts, can we conclude that the resistance R is 4 ohm? If not, is it greater or less than 4 ohms? You can answer this question But the only thing is, if this next part of ammeter voltmeter construction is over, you can answer this. But please remember one more thing. I am writing something here. Ideal. What is an ideal?
Excuse me, sir.
Tell me, Amma.
Sir, I asked the doubt for question 105, sir. You copied 106 by mistake.
105. Okay, okay, Amma. Okay. I'll go back then. 105 you are asking me. Okay. We'll go for taking up that. 105. Okay. Is this okay, Ragini? The ammeter and voltmeter are non-ideal. If an ammeter reads 2.5 ampere, voltmeter reads 7.5 volts, can we conclude that the resistance R is 3 ohm? No, whether it is the previous one, next one, or this one, concept is same, What is ideal? Ideal, I must write like this. Ideal ammeter resistance is 0. And ideal voltmeter resistance is infinity. This is something, of course, just for a few days you wait, then that will be clear. Ideal ammeter resistance is 0. Ideal voltmeter resistance is infinity. Now let us come to this. Ammeter is reading 2 ampere, that's what they are saying. Okay, then I have to say the reading of this is 2.5 ampere. What more? Voltmeter reading is 7.5 volt. Then I must say, by looking at this diagram in this manner, can we conclude the resistance R is 3? Oh, when I is the current flowing, according to Ohm's law, I should say like this, no? I into R plus ammeter resistance, because please see this diagram, R and ammeter are in series. So for total resistance, I should add these two. Current into total resistance should be total PD 7.5 volt. Then what should be R plus R ammeter equal to 7.5 divided by I. That I was given as 2.5. Then you are getting 3 ohm, correct? But the 3 ohm is the sum of capital R and R of ammeter. Therefore, capital R should be how much? It should be 3 minus resistance of ammeter. Am I right? But just now I told you, ideal ammeter resistance is 0. This is not ideal, non-ideal, they are saying. So, definitely this is having some value x. When I subtract x from 3, definitely this value will be less than 3 ohm. I don't know whether able to follow. Ragini?
Yes, sir.
It is less than 3 ohm because you are subtracting something. Resistance of ammeter is having some value. It is 0 if it is ideal.
Sir, one doubt, sir.
Tell me.
Sir, even the voltmeter is not ideal, no, sir.
Exactly.
Sir, so then the current, sir, it will divide into, like some will go into ammeter and some will go into voltmeter. No, sir.
No, that is true. But in such a case, the current, I am saying that the common current through R and A is I.
Oh.
Understood? No, I will draw. No, by seeing the diagram, you will get a doubt. See this? I will draw like this. This is ammeter. You know, this is where voltmeter is there. Ah, no, sorry. This is the voltmeter. But my intention is to say that this current is I. Why you are thinking that this current is I, it is getting deviated? My intention is to say that this is I. Because whatever I is there, that is only recorded by ammeter, no?
Oh, yes, sir.
Is it not, my dear?
Yes, sir.
Because you are seeing this capital R and ammeter in series. That series current only recorded by ammeter, not the total current. As you thought, if some current is coming out of that at this junction, some current will go like this, some will go like this. But that going out current is not recorded by ammeter.
Oh.
Okay. Then what more, please? But of course, from tomorrow, oh, 107 you want. Ma Ragini, what is your doubt? Are you asking me to take up one more, Amma Ragini?
Yes, sir. I want 107 problems.
107 also.
Yeah, it's not a problem, sir. It's just a question which need to be answered. That's it. It's like a.
No, my thing is, no, that all that explanation. Could you answer or do you want me to answer?
I want you to answer.
Okay, ma, that's what. Why all that explanation, my dear? Honestly, I have faith on students that they will work, then only they will ask. Then, 107. Name a non-ohmic device that can have two different values of current for the same applied voltage. You know, voltage should be same, but two different values of current should be there. Better, for the time being, I want you to memorize that should be a diode. But what it is, we will see that, don't worry. Not that mechanically for the total economic year, forever in life you have to remember, no. You remember that as diode, or you can go for writing one more name, thermistor. The name itself is telling you thermal resistor, name is thermistor, whose resistance value changes with temperature. For thermistor and for diode, this idea holds good. But how, we are going to see very soon. Anything more, please? Over. Okay. Then my intention, of course, actually we have so many other problems to work out. But my dear, before going to the problems, shall I assume that you are all clearly hearing me? Are you?
Yes, sir.
I am looking at the chat window. Okay. Anyhow, no, the thing is, from tomorrow, you are being provided with some extra work. Let me hope that, if not 100%, most of you have some wonderful ambitions. That ambition part requires not only 12th. Anyhow, every year what is happening is, students after entering 12th, suddenly they become serious, they become very alert, attentive, they start concentrating on 12th, and at one stage they feel that they are confident with 12th. By that time they feel that they have forgotten every 11th part. But to avoid that, I was doing some homework. I could successfully do that by early hours today. So altogether, you know, taking the whole 11th syllabus, in 12th already electrostatics 2 lessons, charges and fields, potential and capacitance, current, electricity we completed. Total lessons in our 12th are 15. Out of 15, 3 lessons we completed, 12 lessons are remaining. And don't worry, those 12 lessons anyhow will complete in course of time. But what I have done is, the total 11th, excepting that units and dimensions, the whole thing I segregated into 15 parts. Now starting from tomorrow, 1st May, till the end of May, I have taken 30 days. On the average, I allotted 2 days for single lesson. Then in every lesson, of course, whatever you have studied, leave it. By this time, you may be having some doubts, some formula doubts, all that. So for every lesson, I involved, starting from vectors, elements of vectors, I started giving you some theory. Study the theory part. Next, some illustrated, worked out examples are there. That worked out example, simply read the problem, try to answer without seeing my working. Probably you may solve it in a more easy way. Why not? Don't underestimate yourself. Then if you are not able to solve, please see the working. After all that models, every chapter is provided with exercise. So totally in every material lesson file, you have 3 parts. One part is the theory part where you have to see it, reading material. The next is model problems, illustrative examples. The third is exercise. For every exercise, of course, finally key was also given. You can solve, you can check up. So that way, 2 days we are allotting for a single lesson. Theory reading, illustrative examples 1 day. Next day, you'll be going for solving the exercise. That way, alternate days, if you work out 15 chapters, will be 30 days work. With every day, I have given that. Wherever there is a doubt, you please round up that. Only, I have given my email address also in the letter. For that email address, you send your query. Simply question number, chapter name, enough. No need of wasting your time by typing the whole question, because I have all the questions with me. So do that, and at the earliest I'll see that the answers will be pumped to you. But use the holidays. By the end of May, you have to say that, sir, 11th physics, I'm okay. Then, of course, not that it is exhaustive, complete. Always scope is infinity. But I thought bare minimum, approximately 60 exercise problems for everything into the total 15. 900 to 1000 things were sent to you. Totally, I made it into 15 parts. Probably in your mail they might have entered also, because I have sent them, I have given to those people. If not, today, by the end of this class today, you are all to receive the total 15 files. But one extra thing I want to tell you. Of course, if you read the letter, you will understand all that. But the total contents will go to 240 pages. 240 pages, if you take on both sides, you will get 120 papers. I advise you to take it if possible, because every time sitting in front of the computer, seeing back, front, confusing. Better this 120-page file matter, you take a printout, put it in a file, and like our the sacred Gita, you complete these problems, you'll become a happy person by the end of this month. And please, I know there are going to be small difficulties, but even then, I'm not sure. Some people with ambition, they may read the theory, they may solve the illustrated problems, they may complete exercise also in 1 day to some extent. Right? I'm sure by the end of this month, day-wise schedule for physics I have sent today. The letter, please go through that, start working, and by the time the school reopens, you may forget 12, no problem. Anyhow, we'll pump it back to your brains. But 11th class, we should not. Okay? So, please do that work and check your mail. And I'm sure you'll find handful of work. Of course, I don't know. Probably chemistry sir may be sending you something. Math sir may be sending you something. But physics part, today in the early hours I completed, I drafted letter, I gave it to these people. Today your mail boxes will be full with 240 pages information of physics. Please use that, my dears. And again I am telling, not seeing on the computer monitor and enjoying. Better if you take printout all our PDF files. You can take anywhere 120 pages, take a print, you'll feel comfortable. According to the date, what lesson you have to start on first, what on third, what on fifth, day-wise alternate day planning I have given. Please do that and let me see your shining faces by the time the school reopens. But happily you can do the job sitting in your home, right? But as and when there is a doubt, welcome. You can contact me by mail. I'll see that. Wherever I am, of course, I planned something else, a small publication work, but definitely I'll attend it to you people. But don't go for specifying a time exactly during this time. That is why I'm asking you mail. I will be looking into the mail. I'll be, answering your calls. Okay, my dear? And of course, some
Sir,
other. Tell me, please. Is it
sir,
Soumya?
yes, sir.
Tell me.
Sir, for current electricity, sir, the material.
No, current electricity. 1 minute, 1 minute. Current electricity, I found. Hello, my
Yes,
dear.
yes, sir.
No, some people are talking. Let them just come down. No, the thing is, the total reading material for board, I will be sending you if possible by mail, or the minute school reopens, I'll give the print. Okay, na?
Okay, yes,
That happened with the first two lessons. For current
yes,
electricity, I remember I have not given you notes for our board exam. I'll give
yes,
you. And moreover, current electricity, some varieties and ticklish problems. After completing the whole lesson, we have not solved many problems,
yes, sir.
except the few problems sent to your mail in the form of these assignments. Nothing more we have solved. We'll start solving them also with Wheaton plates, potentiometer, all that. We'll do that definitely, and material also you'll get. But anyhow, I'm putting that work to the reopening day for
Okay,
next, sometime in the month of June, 1st or 2nd, no,
yes, sir.
then we'll plan that. But now these days, my personal suggestion is try to stick to that 11th work sent of 240 pages, and please see that anyhow and somehow you'll be completing it with all satisfaction. Will you do that?
Yes, sir.
Please try, all of you, my dears. And now, today I feel that better if we stop here, but I will accelerate these people to send, mail to you people with all that. But better read the whole thing, take a printout. Okay?
Sir, next class will start at 10:20 only, no, sir?
Which one? Next class as usual, 10:20, not immediately.
Okay, sir. Thank you, sir.
Okay, my dear. Thank you.
Thank
We'll
you.
meet. Go ahead.